Polar coordinates rectangular and rectangular back to polar. Hey, it's me again. Very quick video on converting or changing polar coordinates to rectangular and rectangular to polar. To be honest with you, we spend so much time in mathematics graphing on the Cartesian coordinate plane, but think about it. If there's $1 laying on the floor over there, I'm not going to walk a horizontal distance and then rotate 90 degrees and then move toward it. No, I'm going to see it, I'm going to angle myself toward it and go straight to it. That's moving polar. So, polar coordinates, very simple. R, and is the distance. Theta is the angle that you're rotating toward. Some students kind of get them backwards. It seems like you rotate and then go, but whatever. This video, very short, very sleek, very quick. Basic course in trig, you should be talking about polar coordinates and polar equations and so forth. And I'll do some future videos where I take basically the unit circle and show you how to graph these really beautiful polar equations. Got to be careful because they're definitely not functions the ones I graph, and they're so beautiful. And a lot of students take their little TID3 or TID4 calculator, change the mode to polar, and start putting in some trig stuff and get some really beautiful little flowers and stuff like that. So it's pretty cool. But to make a long story short, most universities, once you hit like a Calc 3 course, they'll start going back through some of this information again. But this is very basic. So here's a typical polar coordinate, 6 pi over 6 radians, real simple. Now, these 4 equations that I have here, x equals r times the cosine of theta, y equals r times the sine of theta, r squared equals x squared plus y squared, and the tangent of theta equals y over x. You should already intuitively know that these are true. So if you're taking trig and you're looking at this and going, I don't know where those formulas came from, trust me. A, you haven't done your studying, but second, you really need to know these 4, especially when you go into polar stuff. So you really want to know these 4 equations. And in fact, I'm going to work both these problems without using the equations, even though they're right there. So watch. Like in this example right here, let me just graph what 6 pi over 6 looks like in polar land. So basically what we're doing is we're going out, and for those of you that want me to write 30 degrees, which is pi over 6 radians, and then I go out 6 units. And what I want to do is find out what is that point, that XY point right there. Well, this is pretty simple. We just go ahead and draw our triangle. And then we look at this bad boy and go, I really like to find out what this x value is here and what this y value is, and I've got it. So this is a right triangle. So let me put my finger on 30 degrees right there. So the sine of 30 degrees is equal to opposite y over 6. And then I can also do the cosine. The cosine of 30 degrees is equal to the adjacent over the hypotenuse. And on both of these cases, if I just go ahead and multiply both sides by 6, I get what my y value is. And if I multiply both sides of this one by 6, I get my x value. And lo and behold, that's exactly what was sitting right here the whole time. So you see, y is, come on now. Ain't even doing it. So 6 times the sine of 30, this is pretty simple. The side opposite, and this is a 30, 60, 90 degree triangle, one of our 2 special right triangles. So the side opposite is half of 6, which will be 3, right there. And then this side right here will be 3 square roots of 3. So come on, we already know what the sine of 30 is on the unit circle. I mean, the sine of 30 degrees on the unit circle, if you've got to draw it out again, bump, bump, bump. So here's that 30 degree. This is the ordered pair. Square root of 3 over 2, 1/2. So the sine of 30 is going to be 1/2. 1/2 times 6 is 3. Oh, there it is. So there's our y value of 3. And then square root of 3 over 2 times 6 is 3 square roots of 3. So I didn't even use these 2 formulas. And I just drew the picture and used some old hippie called another hippie. I didn't do tripping on apples. my definitions of my trigonometric ratios in a right triangle, and not only was it a right triangle, it was a special right triangle, I still drew the unit circle. I got the same answer 3 or 4 different ways. Everything's related. Everyone's a suspect. Sorry about that. Screen flashback. So let's do it again. Rectangular to polar. So let me plot the ordered pair 1, -1, which is right there. So this is the ordered pair 1, -1. So what I want to do right now is I want to find out what this r is, and I also want to find out what theta is right there. See, so cute. So what we have right here is we have this 1, which is there, and then down -1. So let me use the Pythagorean theorem. So 1 squared plus -1 squared, that's 2, so it's the square root of 2. So r is simply the square root of 2. I don't think I really needed to spend hardly any time on that one. And now we need to find out what r is, that theta is right there. So keep in mind, what I can do on this one is, since I have the opposite and I have this adjacent, I can simply do the tangent of theta is equal to opposite over the adjacent, which is exactly what this was right here. Oh, I'm using all the same stuff. Oh my gosh. So basically, the tangent of theta is equal to -1. I mean, come on now. We kind of know what that is, don't we? I think we do. I think we do. 45 degrees, yeah, pi over 4 radians, but it's that direction, it's clockwise, so that's -pi over 4 radians. Very simple. These are really fun, really simple. I'm making it out like they're very easy. Sometimes students get to have trouble with these when, like, we have an ordered pair that's on the axis or something like that. But again, one thing I want to stress to you is go ahead and commit these 2 equations. Very simple. You should already know these from previous sections, even though we weren't talking about polar coordinates. And of course, we already know what the Pythagorean theorem is, and we should know that the tangent of theta, one of our basic identities, is sine over cosine. And what is y? Sine. What is x? Cosine from the unit circle. So come on, none of this is new. We just got to put it together, draw a picture. When in doubt, draw a circle, draw a triangle. It is still trig. See you next time. We're changing polar coordinates to rectangular and vice versa.